Increasing and decreasing functions. Question number 5. The interval in which y equal to x square into e to the power minus x is increasing is minus infinity to plus infinity, or minus 2 to 0, or 2 to infinity, or 0 to 2. Let's explore in which interval it is increasing. See the solution. We write fx equal to x square e to the power minus x. Then we find f dash x. Here we can apply product rule. 2x e power minus x plus x square and minus e power minus x. We can take common x e power minus x. Then 2 minus x will be left inside. Here f dash x equal to 0. If we put, then what do we get? X e power minus x, 2 minus x is greater than 0. Why is x equal to 0? Or 2 minus x equal to 0. E power minus x can't be 0 because it is only possible when x equal to infinity. So we write 2 minus x equal to 0 or x equal to 2. Now, for function to be increasing, f dash x must be greater than 0. That is e power minus x times 2 minus x must be greater than 0. Here, e power minus x can't be 0. So x is greater than 0, or 2 minus x is greater than 0, from where we get 2 is greater than 0. So we can say that x lies, sorry, 2 is greater than x. So x lies between 0 and 2. 0 is x is 0 is less than x is less than 2. So interval is this. That is the part 0 to 2. I think you must have understood. Question number 2. Prove that the function f given by fx equal to log cos x is decreasing on 0 to pi by 2 and increasing on pi by 2 to pi. Let's consider its solution. Fx equal to log cos x. F dash x will be equal to minus sin x divided by cos x, that is minus tan x. The reason is d upon dx of log of function will become 1 upon function times d upon dx of function. Here function is cos x, so which is in denominator, and then its derivative is becoming numerator. So this is how we get f dash x equal to minus tan x. Now we are given intervals where we have to check whether f dash x is greater than 0 or less than 0. So f dash x equal to minus tan x. Now we have to consider the interval 0 to pi by 2. We know that in the interval 0 to pi by 2, if we plot the graph of tan x, it goes like this. This value is pi by 2. So tan x is positive. If tan x is positive, then f dash x will be negative. So f dash x will be less than 0. So function will be decreasing. Now, second interval is pi by 2 to pi. Graph will be like this. Clearly, between pi by 2 to pi, tan x is negative. This is the portion. Graph is going downward. So if tan x is negative, in that case, negative of negative will become positive. So in interval pi by 2 to pi, f dash x will be negative of negative, that is positive, which means it is greater than 0. Hence, function is increasing. So our purpose is served. Next question. Let I be any interval disjoint from -1, 1. Prove that the function f given by fx equal to x plus 1 upon x is strictly increasing on I. Question. Fx is equal to x plus 1 upon x. We differentiate it. F dash x equal to 1 minus 1 upon x squared, which is equal to x squared minus 1 upon x squared. Now we put f dash x equal to 0, that is x squared minus 1 upon x squared equal to 0. Further implies x squared minus 1 equal to 0, or x minus 1 and x plus 1 equal to 0, or x equal to 1 and y squared. Now this is minus 1, this is 1, this is plus infinity, this is minus infinity. Question says, I be any interval disjoint from -1 and 1. So we don't have to consider this interval. Only these two intervals are to be considered. So if we consider minus infinity to -1, then f dash x will be here. Suppose we choose minus, and if we put this value here -2, then what do we get? So -2 square is 4, 4 minus 1 is 3, and we can put here. So 4 minus 2 square is 4, 4 minus 1 is 3 divided by -2 square is 4, which is positive. So f dash is positive, so function is increasing. Now let's take this interval. Let's choose x equal to this value here. So 1 to infinity, f dash x will be put here. So 4 minus 1, 3 divided by 4, that is positive. So f dash x is positive, so function is increasing. So here, if we exclude this interval, then we get this function increasing, which is our purpose. Now, question number 4. For what values of a, the function of f given by fx equal to x squared plus ax plus 1 is increasing on 1, 2. Let's see. Fx equals x squared plus ax plus 1. F dash x will be equal to 2x plus a. Now, here we have given interval 1, 2. So we can say that x must lie in this interval. So 1 is less than is 2. So if we want to make it question, but that is also one way. So we want to make it question. So what do we do? We just double it. So it will become 2 is less than 2x is less than 4, and then we add a. So 2 plus a, 2x plus a less than 4 plus. But since f dash x is greater than 0 for increasing function, so 2x plus a must be greater than 0. Now, if we find the value in given interval 1, 2, so if we put 1, what do we get? 2 plus a is greater than 0. And if we put 2, so 2 into 2 plus a is greater than 0. So this will become 4 plus a is greater than 0. Here we get a is greater than minus 2. Here we get a is greater than minus. So we have to consider the least value. So this is least value. A must be greater than minus 2 to make the function increasing in given interval. Now prove that fx equal to 4 sin x divided by 2 plus cos x minus x is an increasing function of x in 0 to pi by. So fx equal to 4 sin x minus x divided by 2 plus cos x. We differentiate it. F dash x equal to 4 cos x divided by, sorry, we should apply quotient rule here. F dash x equal to 2 plus cos x into derivative of numerator, that will be 4 cos x minus numerator 4 sin x into derivative of denominator, will get minus sin x whole divided by 2 plus cos x whole square minus x. Now we open bracket. So 8 cos x plus 4 cos square x plus 4 sin square x divided by 2 plus cos square, so 2 plus cos x whole square minus x. 4 cos square x, 4 sin square x will become 4. And we will get 8 cos x plus 4 minus 2 plus cos x whole square divided by 2 plus cos x whole square. We further simplify 8 cos x plus 4 minus the open bracket 4 plus cos square x plus 2 cos x whole divided by 2 plus cos x whole square. Now, if we open the bracket, so what do we get from here? So 8 cos x plus 4 minus 4 minus cos square x minus 4 cos x divided by 2 plus cos square. 4 will cancel out, and 8 cos x minus 4 cos x will give 4 cos x. So we write it f dash x equals 4 cos x minus cos square x divided by 2 plus cos x. Here 2 plus cos x whole square. Sorry for mistake. Cos x whole square. Now we take common cos x. 4 minus cos x divided by 2 plus cos x whole square. Here interval is 0 to pi by 2. Cos x can't be negative. And here maximum value of cos x is 1. So this term is also positive. So cos x is greater than 0. 4 minus cos x is also greater than 0. Hence, f dash x will be greater than 0. So we can say that 4 sin x divided by 2 plus cos x minus x is an increasing function of x in interval 0 to pi by, which is 55. Now let's go to Next question. On which of the following intervals is the function f given by fx equal to x power 100 plus sine x minus 1 decreased? These are the intervals. Let's consider the solution. Fx equal to x power 100 plus sine x minus f dash x equals 100 x power 99 plus cos x. Now, let's consider various intervals. To interval 0 to 1. So here, if we take this value in radian, so 1 radian, 1 radian will be around 57.3 degree. It means first quadrant. So here in first quadrant, cos x will be positive. This term will also be positive. So this is first quadrant. So if first quadrant, then we can say that f dash x will be greater than 0. So function is increasing. Now let's consider second interval. Second interval is pi by 2 to pi. So here in second, here this is second quadrant, pi by 2 to pi, here cos theta will be negative. If cos theta is negative, so here cos theta is negative, but maximum negative value of cos theta can be minus 1. And here this is 100 times value of x. So overall term means f dash x 100 x power 99 plus cos x. Even if cos x becomes negative, so here if we put the value of x, then this term will be very large as compared to value of cos x. Hence, f dash x will be greater than 0. So in this interval also, f this function fx x power 100 plus sine x minus 1 is increasing. Now we consider 0 to pi by 2. Same thing will happen. This is also first quadrant. So in the interval 0 to pi by 2 being first quadrant, cos x will be positive and this will also be positive. Hence f dash x will be greater than 0 and function will be increasing. It means there is no such interval given here where function fx given by x power 100 plus sine x minus 1 is decreasing. Thank you for watching.